Okay. So the other day, just to kind of recap, we were starting to solve trig equations. And so the first thing that we did was just verifying that the value that they gave us for x was a solution. And that's pretty much where we got and stopped. And then I forgot that we hadn't finished the section. And anyways, so we just stopped there. But basically we were just plugging in the value for x, showing that it was true. We don't like move things from one side to the other when we're doing this. We're just simply solving it out and making sure that it works. And both the ones that we did worked. You should always check whatever answer you get when we actually get into solving them by plugging it in and making sure that it works. But obviously these ones were specifically asking you to do that. So the next thing in here is to find the general solution of the equation. And so we kind of briefly talked about this, but I know it's been a while. But we talked about that there's going to be general solutions, and then there's going to be like solve on an interval. And so it might tell you on the interval from 0 to 2 pi, or it might just say like the general solution, which is where we're going to go back and we're going to be looking at if it's a sine or a cosine, we're adding 2 n pi. If it's tangent, we're going to add n pi, and that covers all possible values that could work for that. So 10, find the general solution of the equation. So we've got the square root of 3 times the cosecant of x plus 2 equals 0. So you're probably going to want to have your unit circle handy also as we get through these, just with what we're going to be doing. But so the first thing I'm going to do is ultimately I'm obviously trying to get x by itself. So I'm going to subtract this 2 over. So I have the square root of 3 times the cosecant of x is equal to -2. Then I'm going to divide by the square root of 3. So we've got the cosecant of x is equal to -2 over the square root of 3. Now, from the stuff that we had the quiz on at the end of last week, how can I rewrite cosecant as something that I know? Because on my unit circle, I don't have cosecant directly. So what's a way to rewrite cosecant?
1 over sine.
Yep. So I'm going to treat this as 1 over the sine of x is equal to -2 over root 3. Now, when I have a fraction equal to another fraction, I can take both of them and flip them over, okay? And that's because essentially I'm like multiplying and dividing, but I can just take them and flip them. So this is going to become sine of x is equal to the square root of 3 over 2, and the negative, I'm just going to stick it out front. So now what I'm going to do is, it's almost like an inverse, but it doesn't follow the same rules as when we were doing the inverses where it's like only can be on the right side for sine and all those things. I'm going to look at my unit circle and say where on my unit circle is the sine of x equal to -√3 over 2. So what two values, and we're going to always do these in radians, gives me a sine value of -√3 over 2. Yes. So we've got 4 pi over 3, and we've got 5 pi over 3. Now, these are general solutions, and this is sine. So what I'm going to do is I'm going to say plus 2n pi on both of them, because this is going to give me all the possible values that would work to give me that. So when it's a general solution, we don't really have to check them back in, because obviously there's like an infinite number of values that work for it. It's just on the specific ones that we're going to be checking them. 12. Sine of x plus the square root of 2 is equal to negative sine of x. So these ones are still general solution problems. So I would suggest that we try to get both signs on the same side. So I'm going to subtract the one from the left over here. So I'm going to subtract sine of x off. So I'll have the square root of 2 is equal to minus the sine of x minus sine of x. So this is going to be minus 2 sine of x. Not squared. They're not being multiplied. So then I'm going to divide by negative 2. So I have root 2 over negative 2 is equal to the sine of x. So now I'm looking at, on my unit circle, where is the sine of x? Negative root 2 over 2.
7 pi over 4 and 5 pi over 4.
Yep. 5 pi over 4 and 7 pi over 4. Now these are general solutions and it's sine, so we're going to add 2n pi to both. And if they were, both of these obviously have been sine. If it was cosine, you would still do the 2n pi as well. It's just tangent that's different. So 14, we've got 3 times the tangent squared of x minus 9 equals 0. So I need to get essentially x by itself, or like the trig function by itself. So I'm going to add 9. So I've got 3 tangent squared of x is equal to 9. Yep, divide by 3, so I have the tangent squared of x is equal to 3. Now, to undo this, I need to take the square root. What happens when I take a square root? It's not negative, huh?
Isn't it just tan x equals square root 3 over
Wait.
Oh, it's just square root 3.
If I have this, what would you tell me the answer is? And?
Oh, yeah, and
It's plus or minus.
Oh, yeah.
So, tangent of x is equal to plus or minus the square root of 3. So, I'm going to look on here, and I'm going to just go with the positive square root of 3's first. Where is tangent positive square root of 3?
4 pi over 3.
What was the second one?
Pi over 3.
Yep. So at pi over 3 and at 4 pi over 3. Now what about where is tangent negative root 3?
2 pi over 3. 5 pi over 3.
So if it asked me, this one, because I'm going to talk about this one because it's kind of a weird one. If it asked me for the specific solution on the interval 0 to 2 pi, because that's what a lot of them are going to ask, I would write all 4 of these. Okay? However, when it's asking me for the general solution, I'm writing one of each one. Okay? Because tangent repeats halfway around. So you told me that it's root 3 at pi over 3, and it's also root 3 down here at 4 pi over 3. That's just simply halfway around, so I don't need to write both of them. I just need the first one. So the answer for a general solution problem is going to be pi over 3 plus n pi. So notice tangent's different here. Or over here, the negative root 3 ones, we had 2 pi over 3 and 5 pi over 3. Again, that's halfway around, just like the other one. So I'm going to pick the first one that I would come to on my circle, which is 2 pi over 3. And I'm going to add n pi. Okay, so with a general solution, I'm picking one of each. With a specific solution, or where it's giving me an interval, I would write all 4. Okay, does that make sense? Okay. Daddy must be thinking about Ryan's shoes. Is he still wearing them?
I think so.
What shoe?
You just need to just find Ryan at some point.
Yeah.
Just look at his feet. That's why I booked it out of homeroom this morning, because I was dying laughing.
I'm scared.
Yeah, you're joking.
I think you should get a pair.
Who?
Jonah. Like all the guys in our class just get matching pairs of shoes.
Jonah, just
It's a good thing he picked this week to do it.
this week. Why?
Think about who's not at school this week.
Oh.
Oh.
Yeah. I mean, you probably do though.
All right, we're moving into now solving on the interval. So this is what it's going to show you. So we don't include 2 pi because 2 pi is the same thing as 0, right? 2 pi is all the way around, but it's up to 2 pi. So we're solving the exact same way. It's just instead of us writing plus 2 in pi or plus n pi, we just write out all the values that are true. So really not significantly different. So number 16, we've got 5 plus 2 sine of x minus 7 equals 0. Now, when I finish these problems, I am going to be checking these ones because these are specific solutions. And on occasion, we might get one that's extraneous. I'm not saying it's going to happen a lot, but it could happen. So, how would I go about solving this?
Add 7 to the other side. Working
Yeah, well, I've got 5 and negative 7, so I would probably say, okay, that's negative 2, and then I would just add the 2 to the other side, but you can do it either way, because I basically got 2 sine x minus 2 equals 0, if you want to see it written that way. Not that you can't do it the way you said it, but just speed the process a little bit. So I've got 2 sine of x equals 2. Divide by 2. Sine of x is equal to 1. So where on my unit circle is the sine of x equal to 1?
Pi over 4? Wait, never mind.
That's tangent.
Pi over 2. Yeah.
Pi over 2. So x would be equal to pi over 2. This is in my interval, so this should be my answer, but I'm going to check it into the equation by plugging it back in and seeing what happens. So we've got 5 plus 2 times the sine of pi over 2 minus 7 equals 0. So I'm going to show that the left side is equal to 0. So I've got negative 2 plus 2 times the sine of pi over 2, we've already established is 1. So negative 2 plus 2, 0 equals 0. So we're good. And you may think, like, is this really, like, necessary? There are some that are going to come out to be extraneous. And you won't know that without checking them. So remember, extraneous is something that it might solve to be a solution, but when I plug it back in, it doesn't actually work to make a solution.
Whatever.
So, the good news is most of these do work out. It's more so like if there's like 3 or 4 values that it comes up to be that sometimes one doesn't work. 18. 3 cosine of x is equal to the cosine of x minus 1. What should I do first?
Move.
Would you subtract the cosine from 3 cosine and 2 cosine?
Yep, I'm going to move this one over here. So I'm going to have 2 cosine of x is equal to negative 1. Yep, divide by divide by 2, not cosine, I said the wrong thing. Equals negative 1/2. So then I'm looking for where is cosine negative 1/2.
2 pi over 3 and
2
2 pi over 3 and 4 pi over 3. Now, a lot of times you really only need to check one of them. So I'm just going to check the 2 pi over 3 one. But we've got 3 times the cosine of 2 pi over 3 is equal to the cosine of 2 pi over 3 minus 1. So cosine of 2 pi over 3 is negative 1/2. So I've got 3 times negative 1/2 is equal to negative 1/2 minus 1. So then I've got negative 3/2 is equal to negative 3/2. And I'm good. But notice, I left everything on its own individual side. That's how you would find if something's extraneous or not. Since I know that 4 pi over 3 gives me the exact same value, like, that's why I don't really need to plug them both in. Like, if it was a tangent one, since those typically are going to end up with 4 values, well, I say that. It could end up with 4 values. I would check, like, the positive, like, one of the positive ones and one of the, like, negative ones if we had, like, a square root. So, like, if I was checking this one up here, I would check pi over 3 and 2 pi over 3, and I wouldn't worry about checking the other ones because it's not going to change anything there. Let's see, 20. Actually, it looks like this one might have something similar to that. 5 tangent squared of x minus 15 equals 0.
Add 15 and then divide by 5.
Yep, so 5 tangent squared of x is equal to 15. If you wanted to divide by 5 all in one step to not have to rewrite it, you can obviously do that. Y'all should be more than capable of doing that if you would like. Yep, so we take the square root, so tangent of x is equal to plus or minus root 3, and then I would list out all the values, which, it's like you said, we already had this one. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now, for the sake of time, I'm not going to check this one. I can tell you that all of these do work. But I would, if I was going to check, I would check pi over 3 and I would check 2 pi over 3 just to make sure that they both work out in the problem when it's all said and done. The times where you're more likely to potentially have an issue is when you have like a trig function on the left and on the right. That's where it could end up coming out to not give you things that equal out. So that's the ones where you need to be more concerned. Not so much these ones where it's like equal to 0. So. And it's not so much unless, I mean, I don't usually write on there like you have to check them, but it's more one of those things where like if you didn't check it and one of them was extraneous, then you're going to lose points. Not like you're going to lose points just for not checking it in general. So just kind of be aware of that too. Find the general solution of the equation. So these ones are just a little bit more tricky, kind of to wrap up this
How
one.
do you know if it's extraneous or you just got the problem wrong? But like,
Well, if I get one that's extraneous, the first thing I'm probably going to do is go back and look at the problem and make sure I solved it correctly. I'm probably going to do a quick check there. But if you write extraneous, like, you're going to have had to have checked it. So I'm going to know, okay, you at least knew something was wrong. Even if you didn't see why it was wrong, like, it wouldn't be as many points off for that. Yeah. I don't see any that at least. Hold on. Specific situation. 16.
what?
I don't see any directly that you're giving an extraneous situation, at least of those ones. The ones that we're getting ready to get into, they're general solutions, but if they were specific, they might would. Just because it's like multiple trig functions in there. Also, the other thing, just to point out, because there wasn't one like this in the problems that we've done so far, but we've only seen tangent being squared and then it having 4 answers. Sine and cosine can also be something squared and could also produce 4 answers as well. Okay, so just be aware of that also, if it's like a plus or minus thing. Anytime you take a square root, it's plus or minus, so then just make sure you look basically on how many solutions it has. Okay, 26. We've got 2 sine cubed of x is equal to the sine of x. So this is one where if it was a specific solution, I would definitely be checking it because I see that there's trig function on both sides. That's one that's, to me, more likely to be a red flag that I could have an extraneous solution possibly. So what I would do to solve this one is I would move this sine of x over to this side. So I would have 2 sine cubed of x minus sine of x equals 0. Now, essentially, it's almost like I need to factor, but obviously, it's not just like x or whatever, but I see that I have a sine cubed and a sine, so I'm going to do basically taking out a greatest common factor. So I'm going to take out a sine of x from both pieces, so I would be left with 2 sine squared of x minus 1. This minus 1 is what people tend to forget. When I take out the sine, it doesn't disappear. It just goes to a 1 instead.
Yeah.
So then, now I can use my zero factor property and I can set each piece equal to 0. So I'm going to have sine of x equals 0. And then I'm going to have 2 sine squared of x minus 1 equals 0. So over here, I'm going to look and say, okay, well, where is sine 0?
2 pi and pi.
So we would say 0 and pi. Now, these are going to be general solutions, so we'll come back around and hit this in a second. This problem isn't a specific situation. This one's general. But I'm going to come back to that, but right now that part has been solved for us. So over here, I need to get this part solved.
Plus 1 divided by 2.
Yep, so I'm going to go ahead and do that in one step. So sine squared of x is equal to 1/2. So now I need to take the square root, and we're going to end up with a plus or minus. So sine of x is equal to plus or minus the square root of 1/2, which this would be the same thing, just to not have to write the whole thing again, as the square root of 1 over the square root of 2. What's the square root of 1? Just 1, so I'm going to get rid of that square root. Can I have a square root on the bottom?
No.
So what do I have to do?
2. Square root 2 over 2.
Yep, so sine of x is equal to plus or minus the square root of 2 over 2. So now, with that, I'm going to look on my unit circle and say, where is sine of x positive root 2 over 2 and negative root 2 over 2?
Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4.
So it happens in 4 spots. So if I was giving my specific solution, all of these values would be written down. But I'm doing general. Okay? So normally, sine and cosine, we add in pi. Okay? Or 2 in pi, sorry. 2 in pi. However, to get from 0 to pi, what am I adding?
May I move your candy cap? Thank you.
Yeah, because I kind of need the whole thing up on the screen right now still. He often ends up in the way. You can just sit him in the box. It's fine. All right, so to get from 0 to pi, what do I do?
Go 180 degrees.
Add pi. To get from pi to 2 pi,
Add 2 pies.
I added 1 pi. Let's try this again. To get from 2 pi to 3 pi, what do I do?
1 pie. Wait, 2 pies, 3 pies. Yeah, that's 1 pie.
Okay, so I'm adding pi.
You say pie.
So while sine, as a general rule, is that I add 2 in pi, in this situation, since it's going from 0 to pi, or those are the two values, I can just say that the first solution is 0 plus n pi. Okay? Because that can be 1 pi, it can be 2 pi, it can be 18 pi, it can be whatever I want, but that's going to be the first one. Then the same thing over here, much like with tangent, okay? But I need to pay attention on my unit circle. It's not like with tangent where it's just like every other one necessarily. So we're looking at the positive root 2's are both on top. So that occurs at pi over 4 and at 3 pi over 4. So in this case, though, I can't just go, okay, well, I'm just adding pi to this one. However, what do I do to get from pi to 5 pi over 4?
Hattie.
5 pi.
Wait. B?
How do I get from pi to 5 pi over 4?
Add 4. Pi over, wait, like.
Okay, finish it. Add
Over
4 pi over 4,
Oh, yeah.
which is
5 pi.
Which
Wait.
is
Pi.
pi. So, even though this one is the positive root 2 over 2 and this is a negative root 2 over 2, both of these are solutions, right?
Yes.
So I can say pi over 4 plus n pi, and that takes care of that one. Now to get from 3 pi over 4 to 7 pi over 4,
4 pi over 4.
Which is
Pi over 4?
Which is pi.
Pi.
Oh, pi. Wait, I was.
You just said
Say
4 pi
pi.
over 4.
at some point today, Addie is going to get this.
It'll be
So we start at 3 pi over 4 and we add n pi.
it makes sense. I just can't like speak it.
Okay,
Really
this
is.
is just a more simple form of writing it. It's not that it's wrong if you write 0 plus 2n pi. Pi plus 2n pi. Pi over 4 plus 2n pi. 3 pi over 4 plus 2n pi.
What is the instant?
So on and so forth. It's just an integer, any number.
Oh.
It's basically because I can keep going around my unit circle an infinite amount of times, and every time I hit an increment of pi over 4, I'm going to have a value of root 2 over 2 or negative root 2 over 2, which was a solution to this equation. So this would be my general solution to this equation. Okay, so I know these ones are a little bit more tricky, but I just wanted you to see them. Typically, we're not finding general solutions, like as far as like when we're actually doing things, we're typically finding it on an interval, but the pre-cal book doesn't even teach this, but I just like to hit it so that you've seen it before in case it comes back up. All right, questions, comments, or concerns?
pretty good so
mean,
far.
It's just 4 pi over 4
Is it easy,
equals
Jonah?
pi over 4, which doesn't make sense for you.
No, I swear, it like it makes sense. I just can't like speak it.
It doesn't make sense because you can't speak it.
No, like.
That's the reason why it doesn't make sense.
You can't defend yourself.
Yeah, you can't speak it because it doesn't make sense.
No,
That's how that works.
It like makes sense in my brain. I just can't like.
Well, your
produce.
brain is upside down.
All right, 3, 5,
If it was upside down, I probably wouldn't be here.
It was a night.
9, 11, 13,
Did you think about that?
17, 19, 21,
Oh my goodness.
and 25. Now, I will give some time tomorrow for you to work as well if we need it. We will probably start the next section tomorrow as well, but I will give you a little bit of time as long as we use the next 15 minutes in here to work today. I don't mind giving a little time tomorrow.
Is there notes on the next section?
Yeah.
Alright.
Yes,
14.6.
6.
Oh yeah.
Yeah, we're not doing 5.
Somebody needs to make sure she has her homework problem for that.
And Addie, just remember, 4 pi over 4
Stop.
is
Pi.
doesn't equal pi over 4.
I-
It equals pi.